Hey everyone, and welcome back to another episode of the Weekly Coder. I'm Chris, and this week we are going to continue finally our Minesweeper game. I know it's been last week I didn't upload a video, and the week before that we did Frogger, and then so it's been like 3 weeks. This is the third week now, so we are due for another Minesweeper video. So before we get into all of this, I'd like to point out that since it's been so long, for me to kind of continue a project after having looked at it in 3 weeks is difficult sometimes because you just don't remember what you wrote, and if your day job includes also programming pretty much all day and doing other things, and then you've also got other side projects that you're working on, and you've got Frogger. There's just so much code all over the place, and you're just like, you just don't remember what you were doing. This is why it helps to comment. You comment everything. Even if it seems completely, ridiculous to comment some things, just comment them anyways. You'll thank yourself later. So, what I did find, though, is that looking through the project gave me kind of like a fresh pair of eyes, since I haven't seen it in such a long time. And I found a couple of things that were wrong that we should fix before we do anything else. And so what we'll do is we'll get into the game script really quick. And we're going to scroll to the reveal adjacent tiles for tile at method. Okay, so now this is our method that reveals all of the adjacent tiles for whatever tile we clicked on to kind of check to see what's around, right? Because the next part of our series is basically working out which tiles are blanks that we should uncover because they're adjacent to the tile that we're checking. Plus, we're also going to add some more stuff that's going to check each tile that was revealed, if it's a blank, to reveal the adjacent blanks around it as well. So, there we go. Maybe we should have called this reveal adjacent blank tiles for tile at. Anyways, we know what this is doing, right? So, first things first. Let's go over this really quick. So if y plus 1, right, y plus 1 because we're checking north, is less than 9 because 9 is the top side of the array. So we don't go any higher than that. We don't go any higher than 8, actually. 8 is our number. So we get to 8, which is less than 9. So once we get to 9, we don't do any checking. Same thing, x plus 1 is less than 9. Also, we get 8, but 9, we don't do any checking. And then we have this situation here. We check south, right? We check y minus 1 is greater than 0. We have to make sure here at this point that we're not just checking to see if it's greater than 0, because we also want to check it if it is 0, right? Y minus 1 equals 0. So we have to do greater than or equal to 0. In that same token, we don't do that. We also do that for x minus 1 is greater than or equal to 0. And then we also want to do it, not here, because we're checking less than 9s. So anywhere where we're checking greater than 0, we want to do greater than or equal to 0. So that same, like, I guess it's just kind of funny how you write things sometimes. You don't want to write -1 because it just looks ugly. But then again, you could also write this in a different way. For instance, you could say, instead of writing y plus 1 is less than 9, you could write y plus 1 is less than or equal to 8. Right? Because we want to check if it's less than 8, but we also want to make sure we check it if it is 8. So that's kind of the same scenario that we're doing here with 0, right? Because we want to check it if it's greater than 0, but also if it is 0. Another way to write that would have been as if it's greater than -1. But that looks confusing, right? That's just going to make the code look confusing. So that's why I always say there's more than one way, or more than a lot of ways to actually write or program something, because everybody has their own style, and this is just my style. So next issue, this one was tough. I kept getting index out of bounds error messages. So when you get index out of bounds error messages, that means that you're checking a part of your array that is outside of its index. So outside of the maximum amount of, things that are stored in it. So if we've got 8 array items that are numbered from 0 to 7, and you check index 8, that means you're out of bounds. So at the place that this happens, and I'm going to give you guys a minute, I want you to scan through this method, this reveal adjacent tiles for tile at. I'll give you guys a minute, pause the video, search through this, and see if you can find anything wrong at all that would cause us to have an index out of bounds search in our array, right? Okay, so hopefully you guys are able to find it. If not, I can tell you where it's at. It is actually right here. So, check tile at x plus 1, x minus 1. That should be your first indicator, is the fact that we're checking x in the y location, which is, doesn't make any sense. So the other part is that we're not supposed to be checking x plus 1 because we're checking in the west. And the west is always going to be negative, so because it's over on the left side. So we need to do x minus 1, right, first of all, and then we need to change this to a y. And because we're checking in the north, we need to go plus 1. So this was all wrong. This was completely just messed up. So hopefully you guys were able to catch that. If you caught it, let me know in the comments. And if not, then okay, that's fine too. It's kind of hard to spot. It took me a while to actually find this. So again, fixing bugs like this is it's part of what we do. It's part of programming. We create bugs and then we got to fix them. So all right, so now what we want to do is we want to make sure that this method is called. Are we calling it yet? Let's see here. So reveal adjacent tiles for tile at, we should be calling it when we check the input. Okay, so reveal adjacent tiles for tile at x, y. Alright, so first thing, we want to make sure that we only call this method if we're actually revealing a blank tile. Because otherwise we don't care. We don't want to reveal any adjacent tiles to any other tiles other than blank tiles. Okay, so we're going to say if tile.tileKind equals tile.tileKind.blank. Alright, and then we're going to just copy or cut this and paste it in here. So if the tile kind is tileKind.blank, then we reveal the adjacent tiles for the tile at xy, which is this tile right here. So let me just fix this up. Okay. So then what happens is it goes in and says, all right, you know what? First of all, I'm going to just collapse this. And I like to do this because if I'm not working with specific methods, such as like the place clues that we're not going to do anything with probably ever again, we're just going to collapse that so that we don't have to look at it. Same thing with place blanks, we're done with that. Place mines, we're done with that. So now it just kind of doesn't take up any room anymore, right? So the only methods we're looking at are the ones that we really care about. We don't need the update either, and we also don't need start. So we're just kind of looking at check input, reveal adjacent tiles for tile at x if the tile that we clicked on is blank. Right. So then we're going through and saying, hey, let's check tile, check tile, check tile, check tile. So if the tile is blank, right? Actually, first of all, yep. So we're setting it to be uncovered because we're setting is uncovered to false. And then what we need to do, because we've already got the part that actually uncovers the tile, okay? So what we need to do is we need to find a way to take all these other tiles that are also maybe blank and actually store them so that we can then check them again. So the way that we're going to do this is we're going to create a list. Okay, so we're going to go up here to our variables, and we're just going to make this public, and we're going to create a list of tile objects, and we're going to call this tiles to check, and then we're going to just do this. That's tiles. Oops, tile. So we're initializing that list. All right. So basically, what's going to happen here? A list you can kind of think of as a dictionary if you know any Objective-C programming. Basically, or yeah, kind of. And then you can also think of it as like an array of sorts. You could add things to the list. You can remove things from the list. You can clear the list. You can get a count of how many items are in the list. So this is all going to help us to determine the other tiles that we need to check, the ones that we didn't click on that could be blank, that are adjacent to the blank tile that we did click on. Right? So, now that we have this tiles to check, what we need to actually do is we need to add, let's see here. So in the check tile at method, and that check tile at method gets called, remember, from our reveal adjacent tiles for tile at, right? So we're checking all the tiles, and then for every tile that is adjacent to our tile, we're checking it. We're saying, hey, is this a blank tile? Right? If it is a blank tile, then we want to add that because we want to further check the tiles that are around it. Right? So we do. We use our new list that we created, and we basically just do this: tiles to check dot add tile. So that tile that is blank, that we know is blank, we're going to add it. Okay. So there's also something else that we should do. We need to check to see if the tile is a clue tile. Okay. We don't want to add it because we don't want to check tiles that are adjacent to clue tiles. But if it is a clue tile, we do want to uncover it. Okay. Because otherwise, there'd be no point to any of this, because we wouldn't see any clues. So we want to uncover the clues if they're adjacent. Otherwise, we don't do anything else. So we're going to say tile.set is covered. I'm going to set that to false. So now that tile see here. Okay. So now what we're going to need is another method that is going to basically iterate over our tiles to check list to kind of figure out what tiles need to be uncovered, right? So we're going to just intelligently call this reveal adjacent tiles for tiles. Tiles for tiles because we're going to be iterating over all of the tiles that are in the tiles to check, right? So for int I equals 0, and then basically what we do is we just say tiles to check dot count, which gives us a count of the number of objects that are in our list currently. And then what we'll do is we will just assign the tile at the current index, right, which is I, to a tile object, and then we will get the current position of our tile and set those to be the x and y's. Whoops. Game object transform local position y. Alright, so now we've got our x and y. Now what we're going to do is we're going to set tile.did. Ooh, we can't do that because we haven't created it yet. So let's open up tile really quick. And we are going to create a new Boolean property. And we're going to call this did check. And we're going to set that to false. And this is just kind of like for us to keep our own like sanity or program to help out to know, hey, we already checked this tile or we didn't check this tile. So if we already checked the tile, we don't care to check it again because that's just inefficient. So we mark the tile as a tile that's already been checked by using that property that we just added. So what we do here then is do tile.didCheck equals true. And then we're going to uncover the tile. So it's covered. And we can do this without worry because all the tiles that are in the tiles to check list are going to be blanks. The only time we ever add a tile to the tiles to check list is if it's a blank tile. Okay, so we can safely uncover all of the tiles in the tiles to check list. So now that we've set that to false to make to uncover it, we have to also check if no. Yeah, no, we don't have to check it at all because we know the tile is a blank tile. Okay, let's do this. We know all the tiles to check list tiles are all blanks, so we don't have to check if the tile is a blank tile before calling reveal adjacent tiles for tile at xy, which is what we're going to do next. We're going to call reveal adjacent tiles for tile at, and then we're going to pass in our x and y of the current tile that we are revealing. All right. So basically, this method, this reveal adjacent tiles for tiles, basically replaces like a click. It does the same thing that we do when we click on a tile, except for it's checking the list of tiles that we added as adjacent tiles. Okay, so hopefully that kind of makes sense in a weird way. So now we just got to call this method, and the best place to call this method is in that same method here, right, where we do reveal adjacent tiles for tile at. So what we want to do is after we get done checking all the tiles at the end here, we want to remove any tile that we've already checked that is in tiles to check. So we're going to do this backwards then. So basically just another for loop, just like we've always done, but we're just going to iterate over it backwards. What happened? So then if tiles to check I did check, right? So if we did check it, which if it got set to true, then we want to remove it. So tiles to check, remove at I. Tiles to check dot count, int I equals 0. No, that's right. -1. Because the reason that we're iterating over this backwards is because if we removed if we did this forward, right? If we just did int I equals 0, I is less than tell us to check.count and I++, right? If we did it that way, then what would happen is if we remove, right, a tile from the index, then that object is removed and the count changes, and then we're going to end up with an out of array index, right? So this way, if we do it backwards, we're saying tiles to check.count, right? No matter how many counts we have, we can always get the last one. I don't know. Hopefully that makes sense. If you need a further explanation, please, comment down below, and we can definitely go over it a little more in depth. So we're removing any tiles that we have already checked, right? Because we don't want to check them again. So now what we need to do is we need to say if tiles to check. So if there's actually any tiles that we need to check still, right? If there's any count left in here, any objects, any tiles that we need to check, then we want to call this reveal adjacent tiles for tiles method, which then iterates over, okay? This then iterates over all of these tiles, and for every tile, it does reveal adjacent tiles for tile at, okay? So it checks the tile, it sets its property to true, then it uncovers it, then it reveals the tiles for tile at. Hold up. Right, no, we're good. So reveal adjacent tiles for tile at, right? So then it goes through and says, hey, I'm gonna check this tile, check it, 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 right? Check it. This is the method that we're calling. And again, all of the tiles that are being checked, they're being checked to see if they're blanks. And if they are, then they get added to the tiles to check list. And if they are a clue, then they get uncovered, right? So it just keeps checking and checking and checking. And then once it gets to the bottom, it says, hey, let's iterate over the tiles to check. And since this one was set to true, that it was checked, it's gonna get removed, right, from the list during the iteration or during the for loop here that we're checking to see which tiles were checked. And then once we get past this, we then say, hey, we just removed one, right? But how many are left? If there's more than 0, then we want to continue to call this reveal adjacent tiles for tiles method, which will then just go back into this, and then we're going to just do this all over again. And this is just going to go on and on and on and on and on until it has no more tiles to check. So I'm going to say that we should be able to take this for a test drive now. So let's save this. And let's go into the Unity UI. Let's press play. Alright, so let's click on a corner. Wow, a mine. So we still have to code that in, and that'll probably be the next episode. What'll happen if you click on a mine, which obviously should make you lose the game. Alright, so here, we clicked on a blank tile. So what happened is it checked all the adjacent tiles around it and said, hey, this one's blank, this one's blank, this one's blank. So each of these got added as tiles that needed to be checked, right? So then it, the order that it adds them in is the order that it checks them in, obviously. So this one would have probably been added first. And then not this one, not this one, not this. I think we do north, east, south, west, and then northeast, northwest, or sorry, northwest, northeast. Okay. So then probably this one, then this one, then this one. But let's just say that we're already at this one. It checks all the adjacent tiles and says, okay, well, this one is a clue, so we're just going to uncover this. But this one's blank, 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 blank. So we're going to add all of these, okay, except for the one. So then these get added to the list, and then it checks all the adjacent tiles around it. It says, okay, well, we have these blanks, so they get added, and then it checks those. And the ones that are clues, they get uncovered. So then, you know, all the way until it gets to, you know, a clue. So the clues are the border tiles that don't allow any more tiles to be uncovered, right? So we should have guessed that that was a mine. So is that, and, all right, see? So this is working exactly like we hoped. If we uncover just a clue tile, it only uncovers the one tile and doesn't do anything else. If we uncover a blank, it uncovers all the tiles that are blank, plus the clue tiles that are adjacent to it, but not if it's a mine. So that is it. That is it for this tutorial. So hopefully you guys got something out of this. The next tutorial is going to be about the mines and how to basically, you know, maybe we'll add the right-clicking so that we can set a flag. Yeah, that might be another tutorial. Could be a whole tutorial, I don't know. I mean, I think that might only take a few minutes to set up. So, yeah, so that's the end of this tutorial, and hope you guys enjoyed it. If you did, give me a thumbs up. Don't forget to subscribe if you haven't already, and tell all your friends about the channel. And don't forget to click the bell for notifications so that you can stay up to date when I release new videos. I'd like to thank all of my Patreons for your support. You guys are awesome. And if you haven't yet, check out my Patreon page. I do release early project and source code before they get posted on YouTube. Actually, the projects and source code don't get posted on YouTube at all. The videos do, but assets, I usually reserve those for my patrons. So if you'd like to check that out, feel free. The link is in the description. Anything else? Nothing else that I can think of. So I'll see you guys next time.